Okay, let's start again for this video. Let's try to do the load combinations for the allowable stress design. As you can see, this is what the still no AISC 316-16 said, that the load combinations associated for the allowable stress design is the ASCE 7 section 2.4. So what is this section 2.4? And that is this one. No, this one. So again, I'll just like you to remind you that we need to investigate the most unfavorable effects from all wind load cases. And we can also does not consider that seismic loads and wind loads will act simultaneously. So anyway, let's go to the ETABS. So as you can see here, this is our gable frame in the previous video, but uh, in the previous video, it is the LRFD or the strength design load combinations from section 2.3 of ASCE 7. Now, I will not show you how did I do this, but just see the video, the previous video, and as you can see, uh, I also created the envelope for 0.6D plus 0.6W, and these are the combos for other loads. So as you can see, we have eight. Since we have three, since we have three different load combinations under ASD, and we have eight load cases, we have 24 overall uh, ASD load combinations, and then I envelope them one by one. So I can also do the envelope for all, add, modify, show combo. So envelope. So this envelope all. Let's three all. So I think we can do this envelope within envelope. I don't know if uh, this will work, but let's try this one envelope. And so this is an envelope within an envelope. So let's just try this, no? Anyway, we can see them one by one, which what envelope is greater, no? Of what envelope is greater among these three load combinations. And under these load combinations, there are eight load cases for load combination. So anyway, let's just review. It is envelope, check. Then this one, okay, sorry. Did I add? Did I add a copy? No. So modify show combo. So envelope again. So don't use linear add in if you just want to do to see what load combinations is higher, no? Then let's try to run. Okay. Uh so okay, it's finished. Then let's try to isolate the main wind force reinforcing system, which means that we need to hide walls and floors. So close, then let's hide. Okay, then let's try extruded view. Okay, as you can see, this is the displacement for, anyway, it's not this displacement we're after. It's um, the load diagrams. Okay, our first load diagram, let's see. Okay, where's the load diagram? Okay, okay, I did not, let's try, analyze, set load cases to run. Okay, I'm sorry, I did not run. Let's run all, so including dead load and live load. So including modal load, no? Let's just run. I forgot to run the dead load, live load. If you did not run the dead load and live load, then the load combination in which there is a dead load, live load, you will not find it. It will not show up. So anyway, let's go here and again extruded view so that, okay, let's see the combo. So the first combo is, let's try the all combos. So let's try the what you call this, the moment diagram. So for the moment diagram, that is moment 33. Okay, moment 33. So moment 33. So if this moment 33, I just like to explain. This is uh, the normal, no? Normal to the loading, no? So as you can see, that is the blue, the earlier the blue, no? The blue. So that is outside. So that is anyway. Just click moment 33 for shear and moment, and for the shear for the moment diagram and for the shear, that is shear 2 2. And obviously axial force. Then if you want torsion, torsion, then etc. So first the moment diagram apply. Okay. Where's the moment diagram? Okay. For the moment diagram here, as you can see, this is done ASD. The maximum shear, the maximum moment is found at what this one? At the end, 15.814, and the maximum moment is found at point 0.2. Okay, I'm sorry. The maximum positive moment is at point 0.2 meters, and the maximum negative moment is at 15. And that is negative 909 and 638 simultaneously. And for the shear, that is 111 and 102. Okay. Then let's try. For this beam, For this beam. Okay, why did it not show up? Okay. For this beam and for this column, let's try. Okay, it's much better if we see the elevation view. Elevation view. Okay. Okay, this is the elevation view of the frame at elevation view 1 or frame at grid 1. Grid 1. So for the maximum moment for the column W16 by 113, as you can see here, we have this auto. This is not designed yet, no? This is just automatic what you call that, sectioning of ano. Okay, that is 102 and show max. So you can find the maximum at 10.8930. That is, I think, at the hmm, it's not really at the what you call that. It's not really at the eaves. So at the eaves, there is no the eaves. This is what you can find at the eave. So it's not really at this point, but there is an offset of almost zero point 0.2, and here almost 11.5 minus 10.875, that is almost 1 meter. Anyway, you can see here. Then this is what we want to use in designing steel if we want to design the steel manually. But when you want ETABS to design the steel, or we let ETABS to select the section, we should not use the envelope load combination, but rather the individual load combination. So you'll get my point. But we can try to use this one if you want to use if you want to calculate manually, no, manual calculation. So the main point of wind load of this wind load playlist is for us to get this shear and moment diagram of uh the most extreme conditions of different load cases. So anyway, that's what I'm talking about, no. So you can see there's no mostly shear here, because it's so little. The shear is so small. Okay, then let's try shear 2 2. It's the same. So shear 2 2 is still the same, no? So let's try axial. So our axial force is 327 for this column, and for this column. Anyway, this is how we try, different load combination. Let's try zero point 0.6. So for zero point 0.6, it's 675, 670, 489 for axial force. Then you can still also try this one by one. So we have 57, we have 289, we have 42. Okay, we have different load cases for the axial load, no? If we want the major shear and moment, it's 1,164. And as you can see, we have a 72 mm using W610 by 0.13. So we have a deflection at 8 meters, that is 72 mm. So later we will try to check that, but as you can see, that is for the load case here, no? So let's try. So the main point of envelope is just to get the maximum and the minimum, or let's say the highest positive and the highest negative moments, shear or axial load, or even torsion if you want to consider torsion of of all the load cases, because but we can still try to do this one by one because it's just 24 load cases. So let's check that. 933. So for this one, it's 1153. It's 9444. I'm talking about moment, ha. So 1164. Okay, okay. Then 800. That is just for this beam, or this gable frame, this beam at B2, no? The B2, or let's say the beam of this gable frame at grid 1, no? It grid 1, of this grid 1. Okay, anyway, of this grid 1, okay, no? I can just zoom it, try. So anyway, I think that's it, no? Thank you. You can also try to display the story response plots, no? One by one. So maximum story displacement for this type. Can find it at 446 mm, 472 mm. So anyway, it's big because our, as you can see, our gable frame is 313, no? 313. That is 313, no? 330, sorry, 30 by 36. So let's try the envelope. So I really doubtful with this envelope, no? But anyway, it's just okay. The envelope is 424 for this, for all. So that is 570. Anyway, that's it. This is what the goal of our playlist of the wind loading, no? So you can go back here and try to understand this one. So this is the shear and moment diagram for the envelope. So I'll try this one. Okay. So this is for ano class, ha? This is only for what do you call that? ASD, allowable stress design. So thank you.